Hi guys! In the previous video lesson, we went over the sinusoidal functions and how to interpret sinusoidal functions from their graphs. We learned the basic definitions or basic labeling of the sinusoidal functions, and we also learned that sinusoidal functions are periodic functions. In this lesson, we will be talking about the parent sine and cosine functions and how to graph the parent functions. Now, first of all, what do you mean by parent functions? Simple example of a parent function is fx is equal to x. This is an example of a linear parent function. Another parent function is fx equal to x squared, which is a quadratic parent function. There are 6 parent functions covered in Introduction to Functions unit. You can watch all the videos in order to understand these functions better. Now, in sinusoidal functions, we have 2 major parent functions that we have to deal with. One is fx is equal to sine x. Another one is fx is equal to cosine x. We already know how to draw these parent function graphs, but now we would learn how to draw these parent function graphs. We also know for drawing the parent function graphs, all we need is the table of values. So we'll first produce this into table of values. So first we're going to be drawing the graph of fx equal to sine x parent function. Let's write the table of values first. This is our table. This is the x value, and now y value is represented with fx. You know this from the trigonometric functions that the sine cycle goes from 0 degrees to 90 degrees to 180 degrees to 270 degrees and back to 360 degrees. So 0 to 360 will complete one full cycle of sine. So we will make a graph of one full cycle. So first x value is 0 degrees, next is 90 degrees, next is 180 degrees, next is 270 degrees, and next is 360 degrees. When we find out, if we want to find out fx, all we have to do is just put in sine 0 in the calculator. If you already know the values, you don't even have to use the calculator. As I know the values, so I know sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is -1, and sine 360 is 0 again. If I turn this into a graph, how would my graph look like is, here goes my x values, here goes my y values, and my x goes from 0 to 360, so it's 0, 90, 180, 270 and 360. My y values go from 0 to 1 and from 0 to -1. So the maximum y I need is 1 and the minimum y I need is -1. I have at 0 degree, my sine 0 is 0. At 90 degree is 1. 180 degree is 0 again. 270 is -1. And 360 is 0. All I have to do is just connect my dots, and this is how my parent sine function graph looks like. Let's now draw the graph of parent cosine function represented as fx equal to cos x. Again, we need the table of values. This is my x and this is my fx. I have my x to be 0, 90, 180, 270, 360. In the same way, in trigonometric functions, you have seen that the graph of cosine function goes from 0 to 360. So it starts at 0 degree, reaches 90, then 180, then 270, back to 360. If I put in cos x as 0, so I get cos 0 is 1. Cos 90 is 0, cos 180 is -1, cos 270 is 0, cos 360 is 1 again. And how do I turn this into a graph is, this is my y-axis, this is my x-axis, y is also my fx-axis. So I have this as 0, 90, 180, 270, 360. The max value again I see is 1 and the min value again I see is -1. At 0 I see a max, so this is my first point. At 90, I see a 0. At 180, I see a -1. 270, I see a 0. At 360, I see a 1 again. All I have to do is again connect my dots. This is how the graph of my parent cosine function looks like.